The morning of March 10th, 1945, Luzon, Philippines. Lieutenant Hiroshi Tanaka of the Imperial Japanese Army's 16th Artillery Regiment crouched in his camouflaged observation post, scanning the American positions through German-made binoculars. His regiment had positioned their Type 96 150mm howitzers in carefully concealed emplacements 3 kilometers behind the front line, a distance his training assured him placed them safely beyond the reach of most American divisional artillery. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed because tomorrow I've saved something extra special for you. Then he heard it. A sound unlike anything in his experience. Not the familiar whistle of incoming shells, but a deeper, more ominous roar. The first round landed 200 meters behind his position. The second struck directly on one of his battery positions. Before he could process what was happening, shells were falling with methodical precision on every gun emplacement in his regiment. Japanese artillery pieces that should have been far beyond American range were being destroyed where they sat. Tanaka would later write in his diary, discovered by American forces after his capture 2 weeks later, that he had believed the Americans were somehow firing from positions much closer than intelligence had reported. The alternative, that American guns could reach this far with such accuracy, contradicted everything Japanese artillery doctrine had taught him. His training manuals specified that American divisional artillery had an effective range of approximately 13,000 meters. His positions were nearly 15,000 meters from the American front line. They should have been safe. What Lieutenant Tanaka did not know, what Japanese artillery officers across the Pacific Theater were discovering, with mounting horror throughout 1944 and 45, was that American forces had deployed a weapon system that rendered Japanese artillery doctrine obsolete. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The 155mm gun M1, universally known as the Long Tom, possessed a maximum range that exceeded Japanese artillery capabilities by margins Japanese commanders initially refused to believe. While Japanese heavy artillery struggled to reach 14,000 meters, the Long Tom could deliver accurate fire beyond 23,000 meters. That seemingly technical difference transformed the tactical and operational reality of artillery warfare in the Pacific Campaign. The psychological impact of this range disparity cannot be overstated. Japanese artillery doctrine, like German doctrine in Europe, had been developed through decades of refinement. Officers trained at the Imperial Japanese Army Artillery School at Narashino learned that artillery positioning followed predictable mathematical relationships. Infantry required fire support at specific ranges. Counter-battery fire demanded that enemy guns be within reach. Logistics dictated that ammunition supply routes remain a certain distance from the front line. The entire system depended on assumptions about what artillery could and could not accomplish at various distances. The Long Tom shattered those assumptions completely. The development of the Long Tom traced its lineage to American experiences in World War I. When the United States entered that conflict in 1917, the American Expeditionary Force discovered it possessed virtually no modern heavy artillery. The largest field piece available was the 3-inch gun, adequate for light support but wholly insufficient for the industrial warfare unfolding in France. The French army, which had suffered 377,000 casualties at Verdun alone, provided American forces with modern artillery pieces, including the 155mm Canon de Grande Puissance Filou, a weapon capable of hurling a 95-pound shell beyond 17,000 yards. American artillery officers who served in France returned home with profound respect for long-range heavy guns. The Westervelt Board, convened immediately after the armistice to assess artillery needs for future conflicts, recommended that the United States develop a 155mm gun with a maximum range of 25,000 yards, nearly 15 miles. The specifications called for a weapon that could elevate from 0 to 65 degrees, use a projectile not exceeding 100 pounds, and be capable of mounting on either tracked or wheeled carriages. Budget constraints during the 1920s and 30s delayed development repeatedly. Prototype designs emerged, were tested, were refined, then were shelved due to lack of funding. The M1000, 920, and M1920M1 were even standardized, but production never commenced. A completely new design started from scratch after 1929 remained incomplete throughout the Depression era. Only in 1938, as war clouds gathered in Europe and Asia, did the final M1 design reach production status. 20 initial production units were manufactured that year. The improved M1A1 variant, featuring a modified breech ring, entered production in 1941. By 1942, the M2 variant standardized further breech improvements that would characterize the weapon throughout its service life. The Long Tom first saw combat on December 24, 1942, when Battery A of the 36th Field Artillery Regiment engaged German positions in North Africa. American artillery officers quickly recognized they possessed a weapon of extraordinary capability. The gun's accuracy at extreme range impressed even skeptical observers. A well-trained crew could place shells within 50 meters of a target at ranges exceeding 20 kilometers, a level of precision that seemed impossible for such distances. The weapon's specifications revealed the engineering sophistication that made such performance possible. The gun used a .45 caliber barrel, meaning the barrel length was 45 times the bore diameter of 155 millimeters. This extended barrel length provided the velocity necessary for extreme range while maintaining accuracy through its rifled bore. The projectile, weighing between 95 and 100 pounds, depending on type, left the muzzle at approximately 853 meters per second. The carriage design incorporated lessons from 2 decades of artillery development. Unlike the box trail configuration common in World War I-era guns, the Long Tom used a split trail carriage. The 2 separate trails spread apart during firing position, providing a stable platform while allowing the gun to traverse through a wide arc without repositioning the entire weapon. This single feature dramatically improved the gun's tactical flexibility, allowing crews to engage multiple targets in rapid succession. The recoil system represented another critical innovation. The gun used a hydro-pneumatic recoil mechanism with variable recoil feature to compensate for different elevation angles. When fired, hydraulic fluid absorbed the tremendous recoil energy, while compressed air recuperators automatically returned the barrel to battery position. This system proved more reliable and required less maintenance than spring-based mechanisms, a crucial advantage in the harsh conditions of Pacific Island warfare. The ammunition used separate loading, with the projectile loaded first, followed by bagged powder charges. This system allowed crews to adjust the propellant charge based on desired range without changing projectiles. A crew could fire at a target 12,000 meters distant, then immediately shift fire to a target at 22,000 meters by simply adjusting the powder charge and elevation. The flexibility this provided made the Long Tom an exceptionally versatile weapon. High explosive shells formed the primary ammunition type. These shells, bursting with devastating effect, could destroy field fortifications, suppress enemy artillery, and break up troop concentrations. Smoke shells provided obscuration for advancing infantry. Illumination shells lit up nighttime battlefields. Chemical shells, though seldom used, remained available. The variety of ammunition types meant a single Long Tom battery could perform missions ranging from precision counter-battery fire to mass-area bombardment. The gun's weight and size necessitated mechanical transport. At approximately 30,600 pounds in firing position, the Long Tom could not be manhandled. The Mach-No 6x6 7.5-ton truck served as the initial prime mover, capable of towing the gun at highway speeds over reasonable terrain. From 1943 onward, the M4 high-speed tractor, a tracked vehicle specifically designed for heavy artillery, became the preferred transport. The M4 could traverse difficult terrain, carry ammunition and crew, and move at speeds up to 53 kilometers per hour on roads. Setting up the Long Tom for firing required approximately 30 minutes under ideal conditions. The crew would unlimber the gun, spread the trails, level the carriage, and prepare ammunition. While this setup time exceeded that of lighter divisional artillery, the Long Tom's range advantage meant it could fire from positions further from the front line, reducing the urgency of rapid displacement. The gun could fire approximately 40 rounds per hour with a well-trained crew, though sustained fire rates typically remained lower to preserve barrel life. 8 battalions equipped with Long Toms deployed to the Pacific Theatre during World War II, the 168th, 223rd, 226th, 433rd, 517th, 531st, 532nd, and 983rd. Field artillery battalions represented American Corps-level artillery, available to support operations across entire island campaigns. Unlike divisional artillery that belonged to specific infantry divisions, these Corps artillery battalions operated under Corps or Army control, deployed where their unique capabilities could provide maximum effect. The Pacific Theatre presented unique challenges for artillery employment. The island-hopping campaign meant that artillery had to be transported by ship, landed across beaches, and deployed on terrain ranging from volcanic sand to dense jungle. The Long Tom's weight complicated these operations, but its range made the effort worthwhile. A single battalion of Long Toms positioned on a small island could dominate an area far larger than its physical position would suggest. Japanese artillery doctrine had evolved through different experiences and priorities. The Imperial Japanese Army emphasized infantry-centric warfare, developing extensive mortar and infantry gun capabilities while paying less attention to heavy field artillery. This doctrinal choice reflected Japan's early 20th century military operations, particularly the Russo-Japanese War and operations in China, where mobile warfare and aggressive infantry tactics proved successful. The Type 96 150mm howitzer represented Japan's standard heavy field artillery piece during World War II. Entering service in 1936, it fired a 43.5 kilogram shell to a maximum range of approximately 13,325 meters, roughly 8 miles. The weapon demonstrated solid engineering and adequate performance for Japanese tactical doctrine. It could support infantry attacks, suppress enemy positions, and conduct counter-battery fire against artillery within its range. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. The Type 91 105mm howitzer served as Japan's standard divisional artillery piece, comparable in role to American 105mm howitzers. It fired a 16-kilogram shell to ranges approaching 11,000 meters. Japanese artillery regiments typically combined these 105mm divisional guns with 150mm heavy howitzers at army level, creating a two-tier system that worked adequately when Japanese forces faced Chinese armies or colonial forces with limited artillery capabilities. The Type 89 150mm cannon represented Japan's longest-range field artillery piece, capable of reaching approximately 19,000 meters. However, production remained limited, with only a few hundred manufactured throughout the war. Most Japanese artillery units never saw these weapons, relying instead on the shorter-ranged Type 96 howitzers. Japanese artillery doctrine emphasized carefully coordinated fire supporting infantry assaults. Forward observers called for fire missions that would soften enemy positions immediately before Japanese troops attacked. The concept of sustained bombardment, laying down rolling barrages, or employing massed fires across large areas, remained foreign to Japanese tactical thinking. Ammunition conservation dictated fire discipline, with each shell carefully aimed at specific targets rather than fired in volume. This doctrinal approach worked adequately in China, where Japanese forces often faced opponents with inferior or non-existent artillery. Chinese nationalist forces possessed some artillery, but in insufficient quantities and with inadequate training to challenge Japanese artillery supremacy. Japanese artillery officers developed confidence in their methods, years of successful operations where their doctrine proved sufficient. The first encounters between Japanese artillery and American long toms occurred during the Philippines campaign of 1944 and 45. American forces landing at Leyte in October 1944 brought with them the full weight of American artillery, including long tom battalions. Japanese defenders, fighting from prepared positions in mountainous terrain, discovered that their carefully sighted artillery positions were not, in fact, beyond American reach. Captain Kenji Yoshida commanded a battery of Type 96 howitzers positioned in the central mountains of Leyte. His battery occupied positions that Japanese calculations indicated were safely beyond the range of American divisional artillery. The positions offered good observation of American-held valleys while being protected by intervening ridges from direct assault. Yoshida's battery could fire on American positions while remaining invulnerable to counter-battery fire. At least, that was the theory. On the morning of November 3, 1944, Yoshida's battery fired a mission supporting a Japanese infantry counterattack in the valley below. The fire mission proceeded normally. Shells landed among American positions. Infantry reported good effect. The battery prepared to displace, standard procedure after firing to avoid counter-battery fire. Before displacement could begin, American shells began landing among the gun positions. The first rounds arrived without warning, without ranging shots, with devastating accuracy. 3 of Yoshida's 4 guns were destroyed in the first salvo. The 4th gun's crew scattered, abandoning their weapon. Yoshida survived by taking cover in a nearby bunker. His subsequent report, captured when American forces overran the position weeks later, expressed bewilderment at what had occurred. He calculated the range from his position to the nearest American artillery he knew about. The distance exceeded Japanese artillery range by several thousand meters. How had the Americans reached his position? His report speculated that American forces had somehow infiltrated artillery much closer to his position without detection. The alternative explanation, that American artillery simply had longer range, seemed impossible. Similar encounters repeated across the Pacific Theater throughout 1944 and 45. Japanese artillery officers positioned their guns according to doctrine and mathematical calculation, only to discover that American counter-battery fire could reach them with devastating effect. The psychological impact of being hit when you believed yourself safe cannot be overstated. Japanese artillery crews began to doubt their own calculations, their own doctrine, their own training. The range advantage the long tom provided created cascading tactical effects. Japanese artillery, unable to reach American long tom positions, could not conduct effective counter-battery fire. American artillery observers, protected by this range advantage, could methodically locate and destroy Japanese guns. Japanese forward observers calling for fire support on American positions found their own guns destroyed before missions could be completed. The artillery duel, that fundamental contest between opposing artillery forces, became entirely one-sided. The mechanics of American counter-battery fire in the Pacific Theater revealed the systematic nature of American artillery superiority. Japanese artillery officers positioned their guns according to doctrine that had served adequately in China and in early Pacific campaigns. They calculated safe distances based on known American artillery ranges. They selected positions offering good observation and fields of fire, while remaining beyond what they believed to be American counter-battery range. The long tom rendered these calculations obsolete. American artillery employed a sophisticated detection and engagement system. Forward observers, typically lieutenants or captains trained specifically in artillery spotting, accompanied frontline infantry units. These observers carried radio equipment that provided direct communication with fire direction centers, controlling battalion, division, corps, and even army-level artillery assets. When a forward observer spotted Japanese artillery firing, he immediately transmitted coordinates to the fire direction center. The fire direction center calculated firing data using pre-computed tables that American mathematicians had prepared during peacetime. These tables accounted for every variable affecting shell trajectory: propellant temperature, barrel wear, air temperature, humidity, wind speed, and direction. altitude differences between gun and target. The tables eliminated the need for time-consuming field calculations. An American fire direction officer could determine precise firing solutions in minutes rather than the hours required for manual computation. The long toms range meant that American counter-battery positions could be located far behind the front line, protected from Japanese direct fire weapons while still reaching deep into Japanese-held territory. Japanese artillery attempting to fire on American infantry positions found themselves under accurate American counter-battery fire within minutes. The mathematical relationship was simple but devastating. Japanese guns could not reach American long toms, but American long toms could reach Japanese guns anywhere within range of American lines. The Battle of Okinawa demonstrated this dynamic at operational scale. American forces invaded Okinawa on April 1, 1945, in the largest amphibious assault of the Pacific War. The 10th Army, comprising both Army and Marine divisions, landed against unexpectedly light opposition. Japanese commander Lieutenant General Mitsuru Ushijima had positioned his forces for defense in depth rather than contesting the beaches, a tactical evolution from earlier Japanese defensive doctrine. Prior to the main landings, American forces secured several small islands near Okinawa. On March 31, 1945, American troops landed on Keisei-shima, a group of small islets located approximately 11 miles southwest of Naha, Okinawa's capital. These islands, barely large enough to accommodate artillery positions, became the site for one of the war's most effective artillery deployments. A group of 155mm long-tom artillery pieces went ashore on Keisei-shima, positioned to provide fire support across southern Okinawa. The long-toms on Keisei-shima could reach nearly every Japanese position in southern Okinawa. Japanese artillery attempting to fire on American forces found themselves under counter-battery fire from guns they could not see, located on islands beyond their observation, firing from positions their own artillery could not reach. The psychological effect on Japanese artillery crews proved as significant as the physical destruction. Japanese gunners knew that firing their weapons invited immediate American counter-battery response. The knowledge inhibited Japanese artillery employment throughout the campaign. On May 4, 1945, General Ushijima launched a major counteroffensive attempting to drive American forces back from their positions around the Shuri defensive line. The attack represented a departure from Japanese defensive doctrine, trading the relative safety of prepared positions for the mobility required in offensive operations. To support the counter-offensive, Japanese artillery moved into open positions where guns could deliver effective fire supporting the infantry assault. The Japanese artillery fired 13,000 rounds supporting the counter-offensive, a massive expenditure by Japanese standards. For a brief period, Japanese guns demonstrated their capability when employed in mass. Then American counter-battery fire found them. The long toms on Keisei-shima, coordinating with divisional artillery positioned closer to the front line, systematically destroyed Japanese artillery positions. Dozens of Japanese artillery pieces were knocked out. The counter-offensive failed, broken primarily by American artillery fire that Japanese forces could neither suppress nor evade. A Japanese artillery officer captured after the battle provided detailed testimony about the effectiveness of American counter-battery fire. His account, preserved in American after-action reports, described the sequence of events from the Japanese perspective. His battery had displaced to a new position before dawn, following strict noise discipline to avoid American detection. The guns were carefully camouflaged, using natural vegetation. The battery waited until the infantry assault began before firing, hoping to achieve surprise. Within 5 minutes of firing the first salvo, American shells began landing among the gun positions. The battery commander ordered immediate displacement, but American fire intensified before crews could limber their guns. 3 of 4 guns were destroyed. The surviving gun was abandoned as crew members fled. The captured officer reported that similar experiences occurred across all Japanese artillery units participating in the counter-offensive. Artillery pieces that had been painstakingly positioned and camouflaged were destroyed within minutes of firing their first missions. Battery commanders faced impossible choices: fire in support of the infantry and be destroyed by counter-battery fire, or withhold fire to preserve the guns but leave infantry unsupported. Either choice led to defeat. The effectiveness of American counter-battery fire at Okinawa reflected systematic improvements accumulated over 3 years of Pacific warfare. American artillery officers had developed standardized procedures for counter-battery operations. Sound ranging. Equipment detected the muzzle blast of enemy guns and calculated their position through triangulation. Flash spotting equipment visually located enemy artillery by the muzzle flash, particularly effective during night operations. Spotter aircraft, flying observation missions over Japanese-held territory, reported artillery positions to fire direction centers. The various detection methods created overlapping coverage that made Japanese artillery positions virtually impossible to conceal once they fired. American fire direction procedures coordinated multiple artillery battalions against single targets. When counter-battery missions were called, fire direction centers calculated which batteries were in range and available. Often, division, corps, and even army artillery would fire simultaneously on a single Japanese battery position. The volume of American fire overwhelmed Japanese artillery units. A Japanese battery might consist of 4 guns. The American counter-battery response might involve 40 or 50 guns firing in coordinated time on target missions. The ammunition expenditure supporting American counter-battery operations would have been impossible for Japanese forces to match. American logistics provided effectively unlimited ammunition. Artillery battalions could fire intensive counter-battery missions without concern for ammunition conservation. Japanese artillery, by contrast, operated under strict ammunition rationing. Even when Japanese guns survived American counter-battery fire, ammunition shortages often rendered them ineffective. Japanese supply lines, interdicted by American air power and submarine operations, could not deliver ammunition to forward positions in sufficient quantity. The Long Tom's role extended beyond counter-battery fire. The weapon's range and accuracy made it effective for interdiction missions, firing on Japanese supply routes, headquarters positions, and troop concentrations far behind the front line. Japanese forces, attempting to move supplies forward or reinforce threatened positions, found themselves under Long Tom fire at distances they believed safe. The weapon created a deep engagement zone, where Japanese movement invited American artillery fire. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The Philippines campaign of 1944 and 45 provided another theatre demonstrating Long Tom effectiveness. American forces landed at Leyte in October 1944, returning to the Philippines as General Douglas MacArthur had famously promised. Japanese forces defending the Philippines understood they faced an existential battle. The loss of the Philippines would sever Japan's access to Southeast Asian resources, particularly oil from the Dutch East Indies. Japanese strategy called for decisive battle, committing substantial forces attempting to defeat the American invasion. Japanese artillery units deployed to the Philippines included some of Japan's best-equipped formations. The defenders possessed Type 96 150mm howitzers, Type 91 105mm howitzers, and various smaller-caliber weapons. Japanese artillery officers selected positions in the mountainous terrain of Leyte's interior, using the topography to conceal their batteries while providing observation of American positions in the coastal lowlands. The terrain seemed to favor Japanese defensive tactics. Steep ridges and dense jungle vegetation concealed Japanese positions from aerial observation. The mountains provided natural protection against direct fire weapons. Japanese artillery officers calculated that American artillery positioned in the coastal lowlands could not reach positions in the mountain interior. The calculations failed to account for the Long Tom's range. American Long Tom battalions landing at Leyte positioned their guns to distinguish to maximize their range advantage. The 433rd Field Artillery Battalion, one of 8 Long Tom battalions deployed to the Pacific Theater, established firing positions near Dulag on Leyte's eastern coast. From these positions, Long Toms could reach targets throughout Leyte's interior mountains, areas Japanese commanders believed safe from American artillery fire. Japanese artillery attempting to fire on American positions around the beachhead discovered they were within American counter-battery range. American forward observers, working with infantry units advancing into the interior, called for fire missions on Japanese artillery positions. The Long Toms delivered accurate fire on targets that Japanese doctrine said should be beyond American reach. Japanese artillery units attempted to displace after firing to avoid counter-battery fire, but the mountainous jungle terrain made rapid displacement nearly impossible. Horse-drawn Japanese artillery could not match the mobility of truck-towed American guns operating on coastal roads. A Japanese artillery regimental commander, captured during the Luzon campaign in early 1945, provided extensive testimony about Japanese artillery operations in the Philippines. His interrogation report documented the progressive degradation of Japanese artillery effectiveness. Initially, his regiment possessed 3 battalions with 12 guns each, a total of 36 artillery pieces. Within 2 months of combat, only 14 guns remained operational. American counter-battery fire had destroyed the remainder. The surviving guns could not fire without immediately drawing American counter-battery response. The regiment effectively ceased to exist as an artillery unit, its guns silent even as Japanese infantry fought desperate defensive battles. The psychological toll on Japanese artillery crews manifested in various ways. Some units stopped firing entirely, preserving their guns but failing to support infantry operations. Other units fired brief missions, then immediately displaced, accepting reduced effectiveness to survive. Japanese artillery commanders reported that gun crews showed increasing reluctance to serve their weapons, knowing that firing invited immediate American counter-battery response. The esprit de corps that characterized Japanese artillery units earlier in the war eroded under the constant pressure of American artillery superiority. The technical specifications that made the Long Tom effective also created operational challenges. The weapon's weight required substantial logistics support. Each gun needed a prime mover, either a truck or tracked tractor. Ammunition supply demanded constant attention, with each shell weighing nearly 100 pounds. A single intensive fire mission might expend 50 shells, requiring dedicated ammunition vehicles and handling crews. Setting up the gun for firing required trained crews working for 30 minutes or more to properly emplace and level the weapon. These logistical demands meant the Long Tom battalions required extensive support infrastructure. American logistics rose to the challenge, providing the trucks, tractors, ammunition, and supplies necessary to keep Long Tom batteries operational. Japanese forces observing American artillery operations saw not just the guns themselves, but the massive logistics tail supporting them. The trucks carrying ammunition, the tractors towing guns, the fuel supplies, the maintenance facilities, all demonstrated industrial capacity that Japan could not match. Japanese artillery officers captured late in the war often expressed professional admiration for American artillery organization. One lieutenant colonel, an artillery instructor before the war, wrote in his post-capture memoir that American artillery represented the culmination of industrial-age military thinking. The Americans had systematized every aspect of artillery employment, he wrote, creating procedures that allowed average crews to achieve performance that would require exceptional crews in Japanese service. The difference was not individual Japanese or American skill, he concluded, but system-level organization and industrial support. The Long Tom also saw service in the campaigns for Iwo Jima, Peleliu, and other Pacific islands. While the weapon's weight and size made it less suitable for small island assaults than lighter divisional artillery, its range proved valuable wherever it could be deployed. On islands large enough to accommodate Long Tom batteries, the weapons dominated the battlefield, reaching targets across entire islands from single firing positions. The Battle of Peleliu in September and October 1944 demonstrated both the capabilities and limitations of heavy artillery in island warfare. The island measured roughly 6 miles long by 2 miles wide, small enough that artillery positioned at one end could reach targets at the other. American forces landed long toms to provide fire support, but the coral rock terrain complicated emplacement. The guns had to be positioned on coral surfaces that could support their weight while providing stable firing platforms. Despite these challenges, the long toms provided crucial fire support, delivering precise fire on Japanese cave positions that lighter weapons could not effectively engage. Japanese defenders at Peleliu had developed sophisticated cave defense systems, tunneling into coral ridges to create positions immune to aerial bombardment and naval gunfire. The long toms' 100-pound shells, fired on flat trajectories that allowed them to penetrate cave openings, proved more effective against these fortifications than bombs or naval shells arriving on high-angle trajectories. American infantry advancing against cave positions could call for long tom fire that would suppress defenders, allowing infantry to advance and reduce positions with flamethrowers and demolitions. The tactical integration of long tom batteries with infantry operations required sophisticated coordination. American doctrine emphasized combined arms warfare, where artillery, infantry, armor, and air support operated as an integrated system. Forward observers assigned to infantry battalions maintained constant radio communication with fire direction centers, allowing immediate artillery response to developing tactical situations. A typical fire mission sequence demonstrated this integration. An infantry company advancing against Japanese positions would encounter resistance. The company commander contacted the forward observer assigned to his unit. The forward observer identified the target location, estimated the enemy strength, and transmitted coordinates to the fire direction center. Within minutes, the fire direction center calculated firing data, selected appropriate batteries within range, and transmitted fire commands. The long toms fired, shells impacted on target, and the forward observer adjusted, fire as necessary. The entire sequence from initial contact to shells on target often took less than 5 minutes. Japanese infantry facing such responsive fire support found their tactical options severely constrained. Defensive positions that should have been able to resist infantry assault for hours or days could be reduced by artillery fire in minutes. Japanese commanders attempting to mass forces for counterattacks discovered that concentration invited immediate American artillery response. The ability of American forces to call down overwhelming firepower on demand fundamentally altered the tactical calculus of infantry combat. The war in the Pacific ended in August 1945, with Japan's surrender following the atomic bombings of Hiroshima and Nagasaki. Japanese military personnel who survived the war carried with them profound respect for American artillery capabilities. Interrogation reports from the final months of the war documented Japanese officers' assessments of American military strengths and Japanese weaknesses. Artillery appeared consistently among the most significant American advantages. Colonel Takashi Saito, a Japanese artillery officer captured on Okinawa in June 1945, provided extensive testimony during his interrogation. His account, preserved in American intelligence files, offered professional analysis from an experienced artillery commander. Saito had served in China from 1937 through 1943 before transferring to the Pacific Theater. He commanded an artillery regiment on Okinawa from January through June 1945. Saito described his regiment's gradual destruction through American counter-battery fire. His regiment began the Okinawa campaign with 36 105mm howitzers organized in 3 battalions. By May, only 12 guns remained operational. American counter-battery fire had destroyed the others. The surviving guns could not fire without, inviting immediate American response. Saito ordered his batteries to fire only brief missions, then immediately displace. But even this tactic proved ineffective. American artillery located and engaged his batteries faster than they could move. The colonel expressed particular frustration with the range disparity between Japanese and American artillery. His howitzers could reach approximately 11,000 meters. American divisional artillery could reach similar distances. But American corps artillery, including the long toms, reached beyond 20,000 meters. Sato's guns could not engage the American heavy artillery, destroying his positions. The asymmetry, he noted, made effective counter-battery fire impossible. Japanese artillery could only respond to American divisional guns positioned relatively close to the front line, while American long toms fired from positions Japanese artillery could not reach. Sato's testimony included technical observations about American place-to artillery procedures. He noted the speed of American fire missions, the accuracy of American fire at extreme ranges, and the coordination of multiple American batteries against single Japanese targets. Most significantly, he acknowledged that American artillery doctrine and equipment represented a comprehensive system his own service could not match. Japanese artillery emphasized individual gun accuracy and careful ammunition conservation. American artillery emphasized mass fire delivered rapidly, with seemingly unlimited ammunition supply. The American approach, he concluded, proved more effective in modern warfare. Post-war Japanese military analysis of the Pacific Campaign consistently identified artillery as a critical American advantage. The Japanese Defense Agency's official war history, compiled during the 1950s and 60s through interviews with surviving officers and examination of wartime documents, devoted extensive sections to analysis of artillery operations. The histories documented the progressive degradation of Japanese artillery effectiveness as the war continued. Early campaigns in 1941 and 42 saw Japanese artillery performing adequately against unprepared or poorly equipped opponents. By 1944 and 45, Japanese artillery had become largely ineffective against American forces employing sophisticated counter-battery procedures and enjoying substantial range advantages. The Long Tom continued serving American forces after World War II. The weapon saw extensive use during the Korean War, where its range and accuracy proved valuable in the mountainous terrain. American and United Nations forces used Long Toms to interdict Chinese and North Korean supply routes, support defensive positions along the main line of resistance, and conduct counter-battery fire. The gun's ability to reach deep into enemy territory made it particularly effective in Korea's linear battlefield, where front lines remained relatively static for extended periods. The weapon remained in American service through the Vietnam War, though by then it had been supplemented by more modern self-propelled artillery. The M107 175mm self-propelled gun and M110 8-inch self-propelled howitzer provided greater mobility and protection for crews while delivering similar or superior range and firepower. The towed Long Tom gradually retired from American service during the 1960s and 70s, replaced by weapons better suited to mechanized warfare. Other nations continued using Long Toms for decades after American forces retired them. Israel employed Long Toms in various conflicts through the 1970s. Pakistan used Long Toms into the 1980s. South Korea maintained Long Toms in service even longer, valuing their range and reliability despite their age. The weapon's basic design proved so sound that it remained militarily relevant for more than 40 years after its introduction. The legacy of the Long Tom extended beyond the weapon itself. The artillery doctrine developed around the Long Tom during World War II became the foundation for modern American artillery practice. The emphasis on responsive fire support, coordination between forward observers and fire direction centers, integration of artillery with maneuver forces, and the willingness to expend ammunition freely to achieve tactical objectives all traced their origins to World War II experiences. The Long Tom demonstrated that artillery range provided strategic advantages, forcing subsequent artillery development to prioritize reach alongside other characteristics. Up next, you've got two more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.